August 4th, 2020. A date that carved an unforgettable memory in every Lebanese heart. The third largest non-nuclear explosion has left our Beirut with a scar. More than 200 deaths, 7,500 injuries, 300,000 homeless, and almost $15 billion property damage. 33.4% out of the total wastes produced were construction wastes. As for our mountains, they are not in a better condition. More than 1,000 illegal quarries occupying abundant areas distributed over such a small area are destroying our nature, resulting in 4.5 million tons of cement produced annually in Lebanon.
Side effects of construction. The consequences of construction, manufacturing, and demolition exceed the boundaries of Lebanon to the whole world. Countries like the US, China, and European Union generate millions of tons of demolition wastes from repair, natural disasters, or even war, whose fate is to be dumped in landfills polluting the underground resources. As for cement manufacturing, 50% of its raw materials are extracted by exploiting natural resources. However, production processes cause the emission of carbon dioxide estimated about 8% of the total greenhouse gases, and the construction consumes 40% of the total energy. No, this shall not go on. A change must be done in the field of construction.
Recycled concrete aggregates. They are heterogeneous material that contains aggregates of original concrete covered with mortar residue originally extracted from structures and pavements crushed and sized. Can be an alternative source for natural aggregates in concrete production. Why RCA? They save around 60% of limestone resources, reduce space required for landfills, decrease CO2 emissions by about 15 to 20%, and save up to 20% of cost.
Now, what are the challenges of recycled concrete aggregates? RCAs increase the water absorption due to high porosity, but decrease the mechanical properties of concrete due to weak interfacial transition zones between the RCAs and cement paste caused by the adhered mortar on their surface. They also decrease the durability, workability, and compressive strength of the concrete. But is this the end? No. Many treatments can be applied on RCAs to remove the adhered mortar and help regain many of their lost properties. Such techniques include CO2 treatments and HCl soaking. Another method that starts by introducing fly ash into the mixture can boost the properties lost by RCAs. But is this enough? Since we cannot give up on concrete, let us use concrete to save our planet. And here comes geopolymers. Alkali-activated clinker-free binder matrix made from industrial waste materials shows a great potential to become an alternative to ordinary Portland cement, having comparable chemical and mechanical properties.
How is it produced? It's the reaction of one or more of raw materials fly ash, a byproduct of thermal power plants, grounded granulated blast furnace slag, byproduct of iron and steel factories, or metakaolin, a dehydroxylated form of the clay mineral, kaolinite, or other materials containing aluminum and silica. With an alkaline activator containing alkaline hydroxide solution or silicate solution, helps dissolve and activate silica and aluminum polymerized in a rapid reaction to form the inorganic polymer.
Why geopolymers? Produced from recycled industrial waste, saving virgin material usage, having remarkable life-saving costs, decreasing CO2 emissions, and reducing the global warming potentials, all while attaining remarkable properties. Geopolymer concrete is our ticket towards a more sustainable future for construction. What about treated RCAs into geopolymers? Demolishing structures into concrete, brick, or ceramic aggregates, then treating them by adding appropriate mineral admixtures, which result in a substance that we can introduce into a geopolymer concrete mix. This ensures the applicability of all construction wastes to be reused as natural aggregate alternatives in structural buildings and an applicable concrete mix.
What closes the loop is the possibility of recycling these structures, known as second-generation aggregates, having better mechanical and durability properties, hence permitting a sustainable cycle with the least percentage of construction wastes. Construction is conservative to change, but substituting cement by geopolymers and aggregates by treated construction wastes is a promising alternative towards a sustainable environment. It started by the idea of reducing wastes and ended by an entire closed-loop cycle to save the environment and heal our planet. So what are we waiting for?